Alright, the last part of Chapter 1 deals with the elements, and this is just a brief overview. Later in Chapter 5, we will actually cover the elements in detail, but let's just have a brief overview now. There are 92 naturally occurring elements. That means there are 92 that are not man-made. Each element has a 1 or 2 letter symbol. You may see some at the end that have a 3-letter symbol, but those are just Greek or Latin letters for the atomic number. That's because they have yet to decide on a name for those. In the symbol, the first letter is always capitalized, the second letter is always lowercase. The periodic table shows the elements organized according to their chemical properties. It's organized in a very specific way. It's one of the most useful tools that a chemist actually has. The columns on the table, also called groups or families, have similar properties. For example, group 1, they're all very reactive, as is group 17. And group 18, for example, is not very reactive. They're inert. We call them inert. Properties vary across the horizontal rows, or we call those periods. If you look on the periodic table, there are 7 periods. That's an easy way to remember. We have 7 periods in a day. There are 7 periods on the periodic table. There are 3 general classes of elements. This is kind of broad classes. Metals, nonmetals, and metalloids. Metals are on the left and in the center of the periodic table. Nonmetals are on the far right. And metalloids are kind of in the middle. There's an imaginary zigzag line. I actually had you write that on your periodic table. A zigzag line. Anything touching that, or most things touching that with a couple of exceptions, are considered metalloids. If you look at this shading, it's kind of hard to tell. This is blue, but this starting right here, including these two down at the bottom, are all metals. Nonmetals are up on this side, and the metalloids kind of occupy. There's a zigzag line that runs through here that touches most of them, and I've got a list of the metalloids here in just a second. And the noble gases finally are in what we call group 18. They are located right here. Metals have certain properties. They are shiny. They should typically have a shiny luster. They reflect heat and light. They're ductile, meaning they can be drawn into wires. They're malleable, meaning they can be spread flat into like sheets, and we can move them kind of like foil. Very tensile. They are good conductors of heat and electricity. That's why we make wiring for our homes out of it. That's why we make pots and pans out of metals. All metals except for one are solids at room temperature, and that one exception is mercury. Mercury is a very interesting element we're going to talk about a little later. Properties of nonmetals. Nonmetals have certain properties as well. They are poor conductors of heat and electricity. They typically have a dull luster. Most of them are gases. They're brittle if they are solids. Little chalky type looking things. The liquid, or the only liquid, is bromine, and it's a dark red liquid. Here are some examples of nonmetals. Sulfur, chlorine gas, and this is iodine, and this iodine is actually subliming. If you remember from the last video, we talked about sublimation. It's actually subliming. Properties of metalloids, they have a kind of a combination of both metals and nonmetals. They are semiconductors, and they are all solids. You typically see them used in technology. They're used to make parts and computers and stuff. The metalloids are boron, silicon, germanium, acetine, arsenic, tellurium, polonium, and antimony. Here's an example of silicon. You typically see silicon used as a semiconductor in computer chips and stuff like that. And the last group of elements is the noble gases, group 18. They are non-reactive, most of the time non-reactive. We use them to store things so things will not react with them chemically, and all of them are gases at room temperature.